So this video is on the classwork that we didn't get all the way through today, doing the last three problems. So this is the solving double angle equation worksheet, number one. So I need to do 4A, I had already done B, and then 5 and 6. And then after the end, I'm going to go back and do the first problems for those of us who need a review on how to do them, or for those who maybe weren't here. So first thing is that today we did learn about some new identities, trig identities, this double angle identity. There are three different versions of the cosine 2x. Notice that there's a 2x. That means instead of it just being cosine x, it's twice the angle value. And so we have these three different identities. All can be derived from each other. And then the sine has its own, that there's only one that they have here. And then the sum and difference identities, where if you're taking the sine of maybe two angles that are not nice ones on the unit circle, but if you add them together or you subtract them, maybe they become a nice one from the unit circle, or you can break something into nice ones from your unit circle. That's what these are kind of for. So we have one taking the sine of alpha plus beta. So here's that formula if it's sine of alpha minus beta. And then we have one for cosine, and we have one for plus and for minus. Okay, so on this one, you'll notice that I've got sine of an angle, cosine of a different angle, minus cosine of that first angle, sine of that second angle. So looking at this, that is looking to me like it's this one right here. So I'm going to use this formula. I'm going to do sine alpha minus beta equals sine of alpha cosine beta minus cosine alpha sine beta. That's the formula I'm going to use. Okay, so I'm going to just write that formula down. So basically what I'm going to do, since this, I have a pi 12ths and I have a 5 pi 12ths, I am going to do a sine of those. So I'm going to have sine of, and I am going to do the pi 12ths minus the 5 pi 12ths, because that's the same as this whole thing right here. Okay, that these are equivalent. Okay, so when I do that math, I'm going to have sine of negative 4 pi 12ths. And I don't know my 12ths on my unit circle, but I can reduce this. And this is going to be sine of negative pi thirds. And I know pi thirds on my unit circle. So it's a negative. So that means I'm going to be starting over here and I'm going to be going this direction. And this right here is where negative pi thirds is. And the coordinate of that point, let me just jot it over here. If you're looking at it, this is going to be short comma long. So it's going to be 1/2 comma negative root 3/2. And we want the sign, and the sign is the y. So my answer is negative root 3/2. That is our answer. And then looking at number 5 and 6. Okay, so 5, what I notice is this right here is going to be sine of twice my angle. This one here is sine of that angle, okay, but this one's twice that angle. So what I'm first going to do is I'm going to draw this on a graph. It says that this is in quadrant 1, so I'm going to draw a right triangle. This is going to be A. And for sine, this is opposite. This is hypotenuse. And then I can do Pythagorean to find my missing side, which let's say is x. So I am going to do x squared plus 2 squared equals 5 squared. So that's x squared plus 4 equals 25. So when I subtract, it's going to be a 21. So that means my x is going to be the square root of 21. So in place of that x, I'm going to put the square root of 21. So now I'm going to look back at those formulas because again, I need a double angle. And so for the double angle, I'm going to use this formula. Sine of twice that angle is equal to 2 sine of the angle, cosine of the angle. Okay, so that's the formula I'm going to use. Okay, so again, let me just do this in terms of A. So this is going to be sine of 2A is going to equal 2 sine of A cosine of A. And I know my sine of A, that was right here. Let me recircle it. I'll circle it in orange. This is my sine. Okay. So I know I'm going to have 2 times my sine of A, which is 2 over 5. And then my cosine is going to be adjacent over hypotenuse. So that's going to be root 21 over 5. And then I'm going to do that math. And I'm going to get 4. 2 times 2 is 4. 4 root 21 over 25. And that's what sine of twice the angle is equal to. Okay. And on number 6, so I'm looking at this, and what I notice is number 1, this is a sine, and this is a cosine, and this is a cosine. So chances are I probably want them to maybe be all cosines possibly. Also, something else to notice is that this is an x, this is an x, and then this is a 2x. That's not the same angle as them. So I'm going to be looking at my 2 cosine 2x, those identities, and see which one will work. So I've got these 3 here. This one would be giving me a 2 cosine squared x minus 1. That would go right here. And that would be good with my cosine x, but I don't know if I want a sine squared x also with that. If I put my 1 minus 2 sine squared x here, that's going to help me with getting rid of this sine. So I might use that. And let's just take a look at this. So here's cosine squared minus sine squared. So if I put a cosine squared minus sine squared, my sine squareds are going to cancel out. This is a 2 sine squared. This is a sine squared. So I would say you could either use the first one or the second one. Okay. So I think what I'm going to do in place of this, I think I am going to use, I'm going to use this first one because the second one is a 2 sine squared, and this is is just 1 sine squared. So I'm still going to have a sine squared and a cosine. I don't want that. I'm going to try to either get cosines or just sines. So I think I'm going to use this first one. So let me just move this down a little bit. Okay, so again, I'm going to use this one here, and I'm going to put it in place of that cosine, in place of my cosine 2x. So I'm going to have my sine squared x, not doing anything to that. In place of my cosine squared x, I am going to be putting cosine squared x minus sine squared x. So again, that was from here, and it's also at the top of our page. Let's see, it's this one here. That's the one I'm going to use. That one right there. Okay. Okay, so, and then let me finish the rest of that equation, equals cosine x. So I am taking sine squared x, sine squared x. In place of this cosine 2x, I'm putting this, and then equals cosine x. So what's going to happen is I have this sine squared minus sine squared. That's going to cancel out. So I'm going to be left with cosine squared x. I'm going to minus the other cosine x to this side. And now I can factor out a cosine x from both of them. And I'm going to get cosine x minus 1 equals 0. So I'm going to try to figure out where my cosine is equal to 0 and where my cosine is equal to 1. Okay, so my cosine is my x. So where is my cosine 0? Where's my x 0? It's 0 up here at pi halves. And it's also 0 down here at 3 pi halves. Now, this was for all. So when I'm doing this, I need to give plus or minus 2 pi n. However, sometimes you can do a shorter distance in between. You have to see. So from here to here, that is pi. Okay, it's half of a circle. And then from here to here, that is also pi. So instead of going pi halves plus or minus 2 pi n and 3 pi halves plus or minus 2 pi n, what I'm going to do is, let me get pink for this. What I'm going to do is I'm going to have x is equal to pi halves, and then I can add and subtract pi n, and that's going to get me to here and then to here, or going backwards. Okay, and so that's going to be one of my answers. And then for the next one, this one here, where's my cosine 1? So again, that's where my x is 1, and that's going to be here. And that's at 0. And then going around 2 pi and so forth. So that answer is going to be x equals 0 plus or minus 2 pi n, or you can just write it as plus or minus 2 pi n. So the two answers here, this is one set of answers. This is the other set of answers. So that's the end of the classwork for those of us who had already done the others. I am going to continue for those of us who want to watch and understand how to do the ones that we did in class, if you missed any of it, or if you were absent. So on a problem like this, you do notice that this is not cosine x, it's cosine 2x. But as long as this was just a number on the other side, we don't have to use those formulas, because those formulas are going to make it much more confusing, because these formulas are going to end up bringing either both a cosine squared and a sine squared, or making it into a sine, 2 sine squared or a 2 cosine squared. So in a case like this, whether it's cosine 2x or 3x or 100x, we can just easily get the cosine 2x by itself. So cosine 2x. So it's cosine of some angle that happens to be 2x. And I'm going to add the root 3 halves to both sides. Then I need to figure out where my cosine is equal to root 3 over 2. And so cosine is your x, so I want long comma short. So it's going to be here at pi 6. And it's also going to be down here at 11 pi 6. Okay, now that's what 2x is equal to, not x. And then you want to pay attention to because we're going for all, okay? And you'll notice that the distance from here to here is not the same as the distance from here to here. So I can't add something and subtract something to pi 6 to go back and forth to my 11 pi 6 in either direction. So I'm going to have to write two answers. So I'm going to go pi 6 plus or minus 2 pi n. And then the other one, let me write it down here, is going to be 11 pi 6 plus or minus 2 pi n. Let me just write that a little nicer. So 11 pi 6 plus or minus 2 pi n. Now we want to solve for x, not for 2x. So I'm going to divide this by 2. I'm going to divide this by 2, which when I do, it's going to go in my denominator, and I divide this by 2. I'm going to do the same over here. And so one answer is going to be x is equal to pi 12ths plus or minus pi n. And the other answer is going to be 11 pi 12ths plus or minus pi n. And so those are going to be our answers. Okay. On number 2. So on this one, we have sine squared x and we have a cosine 2x. And we want to do for all. So we're going to have to do the plus or minus 2 pi n. So I want to look at my identities here and see which one's going to be helpful. So I'm looking at my cosine 2x. And I have a sine squared here. I probably don't want this first one because I would like the sine squared, but I don't want a cosine squared and a sine squared. This one's a cosine squared, so I'm not going to want that. So I'm going to use the second one right here, 1 minus 2 sine squared x. Okay, that's the one I'm going to use. So I'm going to take this and I'm going to put it right here in place of my cosine 2x. Okay, so again, my cosine 2x, and we see it right here. The one I'm going to use is this one right there. So I'm going to go 1 minus 2 sine squared x. And then I still have the minus, let me do it in black. So I still have the minus 1 in that equation and the sine squared x. Okay, so the only thing I changed was my cosine 2x. I substituted this in place. So now what we notice is this 1 and this minus 1 are going to cancel out. And I think I'm going to add my 2 sine squared to the other side, and I'm going to get 3 sine squared x. I'm going to divide by 3, so I get sine squared x. I take the square root, and so when I take the square root, I get sine x is equal to 0. So I want to know where my sine, which is my y, is equal to 0. Well, sine is equal to 0 here at 0, and here at pi, and then back to 2 pi and so forth. So since I can go this direction and this direction, and they're equal distance, they're both pi, my answer is going to be, again, this is 0 and this is pi, but I'm going to take 0 plus or minus pi n, or even just plus or minus pi n. And that's your answer. I don't have to add 2 pi n because I can get back and forth in either direction pi distance. On number 3, so on 3, this one I've got a sine 2x and a cosine x and an x. So a couple places I have issues. I don't always like having a sine x and a cosine x together, but sometimes that's okay. But I definitely have an issue with that being a 2x and that being an x. So I am going to try to put something in place of my sine 2x. So if I'm looking at my formulas, sine 2x, 2 sine x, cosine x. So that's what I'm going to put in. I put 2 sine x, cosine x. Okay, so that's going to be 2 sine x times cosine x. And then I still have that cosine x, and I still have my equal sine x on the other side. So for this, if I clean it up, I'm going to get 2 sine x, and then cosine times cosine is going to be cosine squared x equals sine x. I'm going to get 0 on one side. So I'm going to go 2 sine x cosine squared x minus sine x equals 0. And even though I have a sine x and a cosine x, and I don't really like that, I notice that both of these have a sine x, so I can factor out sine x from both of them. And when I do, I'm going to be left with a 2 cosine squared x in the first term and a -1 in the second. And so now I need to figure out what makes sine x equal 0. And then for my parenthesis, if I set it equal to 0, my cosine squared x is going to equal 1/2. I'd add 1 and divide by 2. I then need to square root. And so when I square root, I get cosine x is equal to positive and negative. Square root of 1 is 1, and the square root of 2 is √2. And then we do need to rationalize. We don't like having a radical on the bottom. So I'm going to multiply top by √2 and the bottom by √2. And when I do, I'm going to get plus or minus √2/2. So that's what my cosine is equal to. And I want to know what angles give me that. Okay. So if I am looking, let me just kind of get this whole problem in. If I am looking at where my sine, so here, let me do that part in, I'll do that part in blue, okay? So if I want to know, hey, where is that true? That's your y. So y is 0 here at 0, and y is 0 here at pi. So that's pi away again, so that's going to be 0 plus or minus 2 pi n. So not 2 pi n, I apologize. It's pi away, so just pi n. So that's one set of answers. And for my other one that's in pink here, okay, that's my pi force. So I'm going to be here at pi force, at 3 pi force, at 5 pi force. That's a 4. And over here at 7 pi force. And then if I'm looking at the distance between these, from pi force to 3 pi force is 2 pi force. From 3 pi force to 5 pi force is 2 pi force. 2 pi force. And here is a fourth and a fourth, so 2 pi force. So I can, for this, instead of writing each of them separately with a plus or minus 2 pi n, I can go x is equal to pi force plus or minus 2 pi force, which is pi halves n. Again, it is really that I'm adding 2 pi force from one to the other. And so that's another set of answers. Okay, so A I already had done earlier, so then B. So if I'm looking at B, okay, I'm looking at my formulas again, and I'm looking at the ones that have cosine, cosine, sine, sine. So cosine, cosine, sine, sine. This one's a minus with the add, and then this one with the plus is with the minus. These are opposite for the cosine ones. And so that's a plus. So that means I want this one here. So I'm going to take cosine of my one angle minus the other angle. Okay. So let's see. Okay, so I'm going to have my pi 12ths. And I'm going to have my pi fourths. So I'm going to have cosine of, and again, this is going to be pi 12ths, and it's minus because it's opposite of the sign that's here. And it's going to be minus pi fourths. These are the same. And now let me just do that math. So that is going to be cosine of pi 12ths minus 3 pi 12ths. So that's going to be cosine of negative 2 pi 12ths. So that's going to be cosine of negative pi 6. So if I'm looking at my unit circle and I'm going negative angle, So negative angle is going to be starting here. And I'm going 1/6, which is right to here. That's where I am. And so that in terms of the cosine, so here, let me just make that a little nicer. So I'm going to be right there. That in terms of the cosine, well, that point is long comma short. So long comma short, cosine is the x. So my final answer is √3/2. And so that finishes all the ones that we had done in class for anyone who missed it or didn't get all of them down.